You will definitely need EN 1990, and you will definitely need the National Annex to EN 1990. I am embarrassed, ladies and gentlemen, because yesterday I met colleagues from the Steel Construction Centre, and we were discussing the content of EN 1990. And after our discussion, I realised that I had misread the Ukraine National Annex. So yesterday evening, I changed my slides. So there are, I think, 4 slides where you will see that I have modified the slide. And when we get to that slide, I will point it out, and I hope that you will mark up your slides. EN 1990 then provides partial factors. So we are going to take the characteristic actions, the 1 in 50-year events, we are going to multiply them by a factor. That will give us the ultimate loads, or the ultimate actions. We will then apply the ultimate actions to the frame. We will do some analysis. That will give us the forces and moments around the frame, and then we will go on and verify the members to those ultimate forces and actions. Now, the partial factors then, very interesting comment in 1990, they assume an appropriate level of workmanship and quality management. So we need to be confident, don't we, that wherever we are constructing, we're going to get this appropriate level of workmanship and quality management. I have very small experience of Kenya in Africa, and I would be a little bit worried about workmanship and quality management in some parts of Kenya. Not all of Kenya, but some parts of Kenya. So we need to bear in mind that we're thinking about European practice, really, common European practice, standards which are appropriate for European practice. EN 1990 tells us about design life, typically 50 years for buildings, typically 100 years for bridges. And it tells us about ultimate limit states, and it tells us about serviceability limit states. Serviceability limit states, we tend to think about deflection most of the time, vertical deflection of beams perhaps, or lateral deflection of buildings. But serviceability also includes a number of things. Floor vibration would be a really important serviceability issue. So with lightweight floors in the UK, with long span floors in the UK, so there is concern about vibration. And to verify that the beam is satisfactory in vibration will be an important part of the design process. Most of our time, we are worried about the ultimate limit state, and we are worried about strength, because we want to know that our member is capable of carrying the ultimate loads, or the design loads. So I'm going to start talking about ultimate limit states, and then finally have 1 or 2 comments about serviceability. So there are 4 ultimate limit states in EN 1990. The final one there is fatigue, and that will be of interest to bridge designers. Not my subject today. The next one up is Geo for geotechnics. So that would be for foundation designers. Not my subject today. The first one is equilibrium. So that would be sliding of buildings or overturning of buildings. We don't normally check equilibrium. Maybe we check equilibrium for retaining walls. That would be a common case, but perhaps not for buildings. But the one we do all the time, 99% of the time, is strength. So I'm going to focus on strength for a few moments. So, as far as strength is concerned, we want RD to be greater than ED. And RD is a very important subscript. And we're going to see, as we get deeper and deeper into the Eurocodes, we're going to see these subscripts appear all the time. So, ED is the design effect. And as far as you and I are concerned, ladies and gentlemen, that will be the ultimate shear, or the ultimate moment, or the ultimate axial force. It's not the characteristic effect, it's the design effect. We've taken the characteristic actions, we've factored them, we've increased them, they are the ultimate actions. So the characteristic actions multiplied by a gamma factor. RD is the design resistance. So generally, you'll see later on, we're going to calculate a characteristic resistance. Here I've called it characteristic strength. And then we're going to divide that by a gamma factor. And of course, we want to make sure that the resistance is greater than the design effect. So first of all, let's think about the actions multiplied by a gamma factor. In the Eurocode system, the permanent actions are indicated with a G, and the variable actions are indicated with a Q. And then the Eurocode talks about 4 varieties of variable actions. First of all, there is the characteristic value, and that value will have come somewhere from the 1991 suite. So it might be the characteristic value of snow. It might be the characteristic value of wind. It might be the imposed load on a floor. It might be the imposed load on the roof. But that is the 1 in 50-year event. And then as you open the Eurocode is going to say, well, in this expression, I want you to take the characteristic action and multiply it by a factor. And I call this one psi naught, this one psi 1, and this one psi 2. And these values will be 1 or less. Generally they are smaller than 1. So the product of this value and the variable action will be a reduced value of action. And the Eurocode is going to tell us precisely when to use those different values. Some of these will be more for concrete than for steel. So some of these hardly ever appear in our steel world. This is what the reduction factors do. So on the top left, you can see that a 1 in 50-year event is very uncommon. But if we take that 1 in 50-year event and multiply it by a value which is less than 1, then that value is going to appear more of the time. If we multiply it by a relatively small value, psi 2 in this case, then that level of load is going to be pretty much there all the time. So for example, if you are designing concrete, you know that concrete takes a permanent deflection, which I would call creep. Okay. The creep occurs under the load that's there almost all the time. Creep is not interested in the 1 in 50-year event. So if you were considering creep, for example, or the permanent deflection of concrete, then you would be probably interested in this value. It's not for you to choose, ladies and gentlemen. The Eurocode defines exactly when you should use these values, and we'll go on to look at those. So these are the combination values, the psi values, and these have been taken from the Ukraine National Annex. And we will see how to use these a little bit later on. For now, all I would like you to notice is that as you go from psi 0 to psi 1 to psi 2, they get smaller. And also notice that the value of psi is associated with a certain type of load. So whether it's wind, or whether it's the roof load, or whether it's office floor load, it has a value of psi that belongs to it. So ladies and gentlemen, we'll continue now. These are the psi factors. Remember that they vary. Psi 2 is smaller than psi 1. Psi 1 is smaller than psi 0. And remember that a particular value belongs to the type of load. If you're considering that type of load, then you need the psi factor for that type of load. And remember that you find these in the National Annex. Now, very importantly, remember we are thinking about the ultimate limit state of strength. We can calculate the ultimate loads using expression 610. So you might know it as 6.10, but today we'll call it 610, or 610A and 610B. And you'll notice that my slide has changed here slightly. So if you are with me in these handouts, you would need to be on page 38. The Eurocode, the core Eurocode says when you're working out the ultimate loads for strength, you can either use 610 or the highest load that you calculate from 610A or 610B. But the Ukrainian National Annex does not allow that choice. And for strength, it says you must use 610A and 610B. So if you look in this excellent publication on page 14, you will see the table towards the top of the page, and you will notice that expression 610 is only allowed for equilibrium. And then when you look at strength, you will see that there is 610A and 610B. So this additional note in your handbook or your workbook is really important. I had misread the Ukrainian National Annex, and I thought you can use either of these options, but that is not the case for strength. You can only use 610A and 610B. So that's a change. Here then is the full horror of these expressions, 610 at the top, 610A and 610B. Horrible, I think, because of the Greek symbols. Horrible because it looks unfamiliar, but actually I suggest it's very straightforward. Let's have a look at 610 first of all, and then we'll look at 610A and 610B. This is simply the permanent actions multiplied by a partial factor. It's no more complicated than that. So I appreciate there is Greek, gamma, there are subscripts. It perhaps does not look familiar. Certainly it doesn't look familiar to a person from the UK, but this is just the permanent actions multiplied by a gamma factor. And the addition sign in inverted commas means combine with. So we are to combine the permanent actions with something else. And the first things that we are to combine with is pre-stress. I can hardly remember, ladies and gentlemen, what pre-stress is. I remember doing it at university, but in the steel world, we are not interested, I don't think, in pre-stress. So we combine it then with a variable action. And if you have more than one variable action, this first one is known as the main variable action or the leading variable action. And all that is saying is there's the variable action Q multiplied by a gamma factor. So I believe, ladies and gentlemen, that you 99% of the time would design floor beams. So we're on a floor here, and the floor beam would be designed for the permanent action and for the imposed load. That, therefore, would be the full extent of the expression. So sometimes in the UK we get rather excited about this and we think that it looks very, very complicated. But actually, for 99% of what we do, it's very, very straightforward. The permanent actions multiplied by a load factor or a partial factor, a variable action, which in our case in this room would be the imposed load, multiplied by a partial factor. Really straightforward stuff. The complication comes when we want to combine more than one variable actions. So if I flick backwards and forwards on these slides, you'll see that nothing is changing. When I add in an additional variable action, those terms stay precisely the same. So the same partial factors multiplied by the same actions. So we only have a new term here, and this is commonly called the accompanying variable action. The accompanying variable action has a gamma factor, so a partial factor, and the value of that gamma factor is precisely the same as the value of that gamma factor. The only addition is that now we've got psi naught. And notice it's not our choice, ladies and gentlemen, whether it's psi naught, psi 1 or psi 2. The Eurocode says, in this one, you must use psi naught. But notice that that psi naught will belong to whatever type of load or whatever type of action. So if this is wind, that will be the psi naught for wind. If this is snow, that'll be the psi naught for snow. So let's imagine then that we have a situation where we've got wind here, and we've decided that in this case wind is the leading variable action, and we've got snow here. There is another condition to check, and that would be snow as the leading variable action and wind here. So if we have two variable actions, there are two situations to check. One of them as the leading variable action, and then the other one as the leading variable action. And that is an important difference because the psi naught value may well change depending on the type of variable action. If you have three variable actions, then number 1 will appear here, number 2 and 3. Then you would put number 2 there, and number 1 and 3, and then you would put number 3 there, number 1 and 2. So the more variable actions there are, although you see one expression there, you'll be checking a number of different situations. Remember, most of the time, in many of the things that we design, we only have one leading variable action, because we're interested in perhaps the load on the floor or the load on a roof. And therefore, our expression is limited to the permanent actions plus the variable action. Now, this is expression 610A, and as you compare and contrast 610 with 610A, you'll notice that the only difference is that we now have a psi naught on the leading variable action. And psi naught is less than 1, generally. So that the answer that you get from 610A is generally reduced compared to 610. This is 610B, and again, if you compare and contrast 610B with 610, the only difference is this Greek symbol here, which I think is called he. Somebody on my left thinks it's called Xi. Somebody's shaking their head over there. Today, we will call it this funny symbol. Okay. So out of the Ukraine nationalics then, these are the values of the partial factors, but remember, you can only use 610 for equilibrium. So again on this slide, I've made a change, look. So if you're following with the slides, notice that 610 is only appropriate for equilibrium. Here are the values for the one that we are interested in, because we are considering strength at this moment in time, and the Ukraine nationalics says you must use 610A and 610B. So here you see the partial factors for permanent actions, for variable actions, and for this funny symbol where the Ukraine nationalics takes the recommended value of 0.85. So, first of all, we might be interested in 610, but of course we're making a mistake. I am making a mistake because we cannot use 610 for strength. So if you are with me in the notes, you ought to make a note that you cannot use 610 for strength, you must use 610A and 610B. I think that's the last change in the notes, ladies and gentlemen. So here is 610A. So we have the permanent actions multiplied by 1.5, and I'm imagining the situation where we have two variable actions. So the yellow cell here is the leading variable action. So in this combination, this is the leading variable action. In this combination, this is the leading variable action. And from a few slides ago, you'll remember that the leading variable not only has the gamma factor, 1.5, it also has the psi factor. And that will be the psi factor that belongs to that type of load, in this case the floor load. Then we have the second variable, or the accompanying variable action, and that also has the gamma factor, which is always the same, multiplied by psi naught. This is a slightly strange situation, because psi naught in both of these cases is 0.7. But in general, it will vary with the type of load. So you need to be very careful when choosing your psi naught values. This then is 610B. So notice in 610B, there is no psi associated with the leading variable action. So here is the leading variable action, here is the leading variable action, just the partial factor of 1.5. But now we have this value of 0.85, which is applied to the permanent actions. So a little summary then. Notice I've made a change here. If you're considering strength, 610A and 610B must be the ones that you use in the Ukraine. If you were in the UK, in fact you could use 610 or 610A or 610B. So that choice is allowed in the UK, but not in the Ukraine. Now, ladies and gentlemen, immediately following page 44, you have a numerical worked example for you to do. It's page 44 of your workbook. So I've reminded you of the expressions. I've given you the various values of factors that you will need. And over on the second page, there is the opportunity for you to substitute everything you know into these expressions. At the bottom of the first page, you realise that I was asking you for 610 and 610A and 610B. Well, because of what I understood yesterday, please don't do part 1, don't do 610, just do 610A and 610B. I think this will take you about 90 seconds, ladies and gentlemen, so have fun. Final reminder from me, remember I made a mistake in preparing these slides because I didn't pay enough attention to your national annex. You can only use 610A and 610B when you're calculating strength. And I believe that most of the time we are interested in strength. So please highlight the fact that 610A and 610B are the expressions that you should use. This is a roof. It's an industrial sort of structure. There are special rules in the Eurocodes for a roof. So here is the code clause. It's from 1991-11, and it says when you are designing a roof, you do not combine imposed loads with snow. You do not combine imposed loads with wind. And the reason for that is that in the Eurocode, the imposed loads are taken to be people, as I said earlier on. So if you have the 1 in 50 year snow load, would you have people on the roof at the same time? And the Eurocode says that's very unlikely, so you don't consider that possibility. If you've got the 1 in 50 year wind load, would you have people on the roof at the same time? And the Eurocode says that's very unlikely, so you don't consider that possibility. Now, in other courses, people have said to me, well, actually I'm designing a platform for viewing the snow, in which case you would have people and snow at the same time. But for the ordinary case of a roof, the Eurocode says you don't consider it. So if you have this 1 in 50 year event, do you have people on the roof? Well, the Eurocode says generally not. There are other combinations of actions, so I've spoken about accidental actions earlier on. So at the top of this screen, you see the combination for accidental actions. Notice that there are no gamma factors here. This is just the permanent action, so the characteristic value, no partial factors. Notice that there are no partial factors applied to the variable action. There is the option of Psi1 or Psi2. That choice is left to the national annex. Your national annex says use Psi1. And that's a reflection of the accident. That's a reflection of the accident being when the floor is loaded in its real condition. So not the 1 in 50 year event, but the real likely event.